G4D, speech processors, S meters, sideband operation near band edges. What's the purpose of a speech processor as used in a modern transceiver? Now, we've been talking about signal processing on the receiver side. This is in the transmitter side. And what it's doing is increasing the intelligibility of transmitted phone signals during poor conditions. In other words, it's taking your microphone input from your voice and processing that to give improved intelligibility of your signal. Speech processor in a modern transceiver. Which of the following describes how a speech processor affects the transmitted single sideband phone signal? What it actually does, it increases the average power. It brings low levels up and it takes high levels down and makes the average power more even, allows the automatic level control to work more smoothly than it would without the processing. Which of the following can be the result of an incorrectly adjusted speech processor? You can get distorted speech, you can get splatter, you can get excessive background pickup. All of these choices are correct. What does an S meter measure? Okay, now, what's the only thing you see in your answers there that has an S in it? Signal strength, right? That's what an S meter measures, is signal strength. Here's what an S meter looks like on a receiver. And here we have a signal that is at S8. Okay, and then it goes to S9, then over 9, we go decibels over 9. We'll talk about that in a couple of questions later here. This is the S meter measures signal strength, received signal strength. How does an S meter reading of 20 decibels over S9 compare to an S9 signal, assuming a properly calibrated S meter? 20 decibels of signal strength, we probably talked about this back when we were talking about decibels before, is 100 times stronger. So the comparison between a signal and a signal that's 20 dB stronger is 100 times stronger. And that would indicate right up here at S9 plus 20 on the S meter. Where is an S meter found? It's found in a receiver. How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9? Okay, the power change, the signal strength change from one S reading to another is about 6 dB, which corresponds to about 4 times the power. Okay, so you would have to quadruple the power of your distant transmitter to raise your signal strength from S8 to S9. What frequency range is occupied by a 3 kilohertz lower sideband signal when the displayed carrier frequency is 7.178 megahertz? So we're 7.178 is the carrier frequency, and we have 3 kilohertz lower sideband, and that's going to give us, we'll be using a bandwidth of from 7.175 to 7.178. Here's what that looks like graphically. And it looks like, well, they shifted a little bit in the translation, but not bad. So our carrier's at 7.178 right here, lower sideband. We're going to be going down here to 7.175. Okay, 7.178 carrier, lower sideband to 7.175. What signal range is occupied by a 3 kilohertz upper sideband signal when the displayed carrier frequency is set to 14.347? Same basic picture. Carriers at 14.347. The top of the signal will be at 14.350, 3 kilohertz higher, with an upper sideband. How close to the lower edge of the 40-meter general class phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower sideband? The closest you want to go to that bottom segment is 3 kilohertz above the edge of the segment. Okay, because if you go any lower than that, you're going to have signal hanging off the edge of the segment here. So this is going to be the lower edge plus 3 kilohertz for your carrier. How close to the upper edge of the 20-meter general class band should your displayed carrier frequency be when using 3 kilohertz wide upper sideband? Same principle, upper instead of lower. Here's the top edge of the band. You want to keep your carrier at least 3 kilohertz below the edge of the band.